Every industry faces the same challenge: how to optimize complex operations efficiently. Dennis Pegden, simulation award-winning industry pioneer and founder of Simio, solved this with a simple yet powerful vision: to make advanced digital twin technology accessible to everyone. Simio breaks barriers. We serve all companies, academic institutions, commercial enterprises, and research organizations alike. Our democratized approach seamlessly combines Python analytics, NVIDIA Omniverse environments, neural network intelligence, and enterprise-grade scalability, all powered by our robust simulation engine. Don't take our word for it. Hear directly from our customers.
By using Simio, we found that we can really see congestion and understand it better than with our Excel model and using that previous tool that we have.
From production lines to patient care, from warehouse operations to workflow management, Simio's digital twin solutions know no boundaries. Simulate what-if scenarios with an intelligent digital twin powered by Simio Simulation. Visit simio.com to unlock your operational potential.
Greetings and welcome to the Simio Solution Series 2026. Today's session, Simio 20 Revealed. We're going to talk a lot about Simio 20 today. Simio 20 was just released within the last month or so. We're going to deep dive into a lot of new features that you're going to see. For those of you who don't know me, my name is Dan Vasilini. I run the sales organization over here at Simio. Doing most of the presenting, though, is going to be Drew Rose. Drew leads our solution engineering team. You will see on the screen there both of our email addresses. I put those up there just in case you have a question today, and that question does not get addressed during today's session. We will do our best to get to questions. I know today's session does have a lot of information in it, and we're going to try to get through it and leave time at the end for questions, but there is a chance we might get to the end and have time for just a few questions. So there's our email addresses. Jot them down in case for some reason you do not get to ask your question during today's session. A couple of housekeeping items before we get started today. Today's session is being recorded for replay purposes. So if you'd like to go back and rewatch this session or suggest it to a friend or colleague, we will provide the information on where to get it. You will see on the right-hand side of this screen on the Simio webpage, just go to simio.com, and right along the top, you're going to see a Learning tab. Under the Learning tab, there will be the Simio web series. That's the solution series. So you can find all of our solution series that we've recorded, including this one. This one usually goes up in about 24 hours after we're done with it. One thing to note before I jump into the next bullet here, this session, obviously, it's July. It's our first session for this year, but we did have our Simio Sync conference earlier this year, which occupied a lot of our time. During that conference, we had a lot of good customer presentations as well as some Simio presentations. You can find that information in the same place. Under the Learning tab, Simio Sync conferences, one bullet down from the web series. And you can find 2026 recordings as well as all of our prior conferences we've recorded back to, I think it's 2021 or 2020. So I highly encourage you to go in there. There are a lot of really good presentations in 2026. Please get in, take a look at them, and let us know your feedback on them. All right, next. Please note, everyone's going to be on mute going into today's session. We will leave you on mute throughout the entirety of this presentation. If you do have questions, we will provide information on how to type your question in. And like I said, we will do our best to get the questions. We do have a lot of information. If we do leave time at the end, we will get to as many questions as we can. You had Drew and I's email address in the prior screen. So if we don't get to your question, feel free to type one in and leave it for us. Okay, that's it from me today. Thank you for attending. We do appreciate it. I'm going to turn things over to Drew, and he's going to get into the session. Drew, the floor is yours.
All right. Thank you, Dan. So good morning to everyone. As Dan mentioned, my name is Drew Rose. I am the team lead for the solution engineering group here at Simio. I work with a lot of our customers and prospects across a wealth of industries and applications. I'm looking forward to discussing the latest public release of Simio, that being version 20. And I think today we'll cover a range of topics and really explore how the new feature set that is in this new major release can be beneficial to a number of different workflows and enable a full set of new capabilities within your simulation models. So among what we'll look at today, and before we really get into the matters at hand, really the best place to review the sprints themselves, and especially the public release, is through our My Account page. That is where we comprise all the sprints of 281 up to 290. And My Account is the one-stop shop to review release notes, to access each downloadable version of Simio, and there's also a wealth of other applications and features within My Account. So if we look at that here, just a quick pan just to review My Account, I have access to a knowledge base showing all the different types of best practices, modeling approaches, things of that end. It's also an opportunity to log and submit your support cases if and when those need to occur. It also gives you access to download the latest public release, as well as any other sprints that may have occurred prior to the public release. So especially if you're eager to get new features, My Account is the way to do so. So let's review what we're going to discuss today. So number of different topics here. We'll start with our Python importers and exporters, and you'll see Art Vandelay on the right, emphasizing that in the latest public release, we're going to be focusing on both the imports and the exports. We'll also discuss some visibility enhancements within process logic and the ability to access different token counts, see what current step we are within a process. So we'll discuss some features there. We'll also look at the watch window, and within the watch window, we can access the items within a given entity, as well as the different aspects of a material element and some stock reservations, among other topics. There's also a new set of dashboard capabilities where we can specifically define Gantt charts within a dashboard, as well as make use of targets as a data source within dashboarding. And there's also a host of other user experience improvements we'll touch on, and that's going to be covered as well. So with the first topic today, that being Python importers and exporters, as we think about our digital twins that are occurring nowadays, there's a wealth of access points that we can tap into potentially for use within simulation. And just looking at the slide here, any given process digital twin we consider today, there's maybe the consideration for pulling in MES data or IoT data, databases, data systems, Snowflake, you name it. There's a lot of information that we would want to use as part of our simulation. So the best way to do that has been enabled with our Python importers and exporters. And we'll look at examples of each of those today. So our importers, just highlighting a few features of why you may consider them as part of your simulation efforts, is to automate that model configuration from those external sources that I mentioned. So if you're looking to pull in your MES data and your ERP data, the importers can enable that and ensure a predictable workflow. Also, we'll look at how we can pre-process and validate that data prior to the model initializing. In a moment here, we'll look at a case of non-rectangular data where we need to convert an Excel spreadsheet into a suitable form for simulation purposes. We can also centralize that import logic. So rather than having to pull in all these different queries from multiple locations, we can have a sole source of truth within the model. And then we support the different enterprise integrations. We've mentioned this a few times, but CSVs, SQL, REST APIs, ERP, all of which can be accessed through these importers. So let's look at some examples. So a lot of first models and a lot of for simulation models, it is not uncommon where maybe a set of input data would look something like this. So in this particular example, we have 3 different products that we're producing at this manufacturing facility. We produce housings, brackets, and covers. We specify different attributes, but as you can tell here, while the information here is useful, it is in a bit of a scattered form, meaning that it is a non-rectangular fashion. And as any Simio user would know, there's a certain structure that we are looking for simulation input data. We need to get this into a rectangular fashion as is used by Simio itself. So let's turn this data set into a structure that is conducive for Simio modeling. So opening up a new Simio here, within our Simio model, I want to pull in that Excel sheet into a form that is useful for my purposes. So let's walk through that. So I'm going to add in a new table, and this table is going to pull in that Excel sheet and put it into a form that is useful for my purposes. So I'm going to name this my manufacturing data, and I'm going to set up a Python importer to access that data, convert that into a use of form, and then have that as an input. So going into our data connectors, you'll see now that we have a new set of feature ribbons for scripting. So specifically in this case, I want to create an import script. So on that import script, I'm going to convert Excel, we'll name it. And on this script, this is going to be specifying what behaviors we are seeking to enact. So when I go to edit this script, and this will pop up an IDE. If there's any questions on that, we have some documentation to support that. But I'm going to assume that if you're at this point, you're an adept Python user. And so I have a script I'm going to use in this particular case that performs that data transformation. So I have the shell that this is what Simio gives me to start out with. And I'm going to import my script here, and let's copy and paste. So bear with me here 1 second as I access that. So I'm going to copy in my script. So this script is going to do the behavior of the data transformation, getting it into a useful form. And you'll note that when I upload this # with package is going to prompt Simio to download these packages as part of my file. So I have OpenPixel and pandas as part of my input. So let me close that for a moment. So I've uploaded my script. And as it's going through, it is going to install those packages. So that pandas, OpenPyXL, those are going to install. It's going to take a moment. And those will be loaded into the directory of this file, of the Simio file, that is. So as we build in the script, we're going to need to add in a few other details to get this to fully work. So what this script will do is it is going to take that Excel sheet, and it is going to convert that into a CSV that can then be inserted into that table that was just constructed. So give it one more minute here to finish up. So once that is done, we now have our script ready to go. But we also need to supplement it with the Excel sheet that we're using. So in that particular case, we need to open up the scripts directory. So within that scripts directory, as well as any different Python scripts that I may have inserted as part of the conversion, I'm going to also need to load in the Excel file that we just referenced. So taking that, I'm going to copy and paste that cycle time sheet that we just reviewed that is being uploaded, and this is going to be fed into that Python script for that conversion to take place. So we've added in the Excel sheet, we've added in our script. Now we need to finish out to say, on this table, what should it expect as far as an input? So this table is actually going to be a CSV importer. So on this CSV importer, we're going to load in the directory that we should access for that CSV. And so this is a unique convention to these importers with these square brackets. This import script data folder is going to be the temporary directory that it contains the CSV that is created when running that Python importer. So I'm importing this, and this is an important and necessary step. When we add in that folder, I'm then also going to now say what file will be produced after that importer is ran. So that's where I'm going to once more say this routing data.csv is the CSV file that will be produced by the importer, and that is going to occur when I run. So when I go and have this set up, so let's just to summarize, I've created my script, I've added in the Excel sheet that I wish to convert, and then I've also specified the importer of where we're going to store that file that is created. So with all that inserted, now I go to import, and what we get as an output is going to be some nice rectangular data containing each product, the operations, the cycle times, and now I have my input to begin my Simio modeling. So just to review, we took this Excel sheet that maybe is very common to our day-to-day workflow, and rather than having to do all this macro development and things within Excel to get it to behave how we'd like, that is going to be done automatically with the importer, and now we have that input that we need. So that's one very common example of where these can be especially useful is to get your data of your systems into a ready-to-use form for Simio modeling. So looking at another example here, we're going to also consider now, maybe we want to consider a small manufacturing operation that has 3 different operations to it. So we have products that come in at a certain arrival rate, and we as a business need to determine how many stations do we need at cutting, welding, and shaping based on the intended volume, and then the relative processing times of each station. So in prior versions of Simio, we would have to fully specify each iteration of the machine combinations that we may wish to consider. But with these Python importers, we can auto-create different quantities of these objects and directly experiment with those in one location. So seeing the mechanics of the previous example, I won't go through each and every step, but same premise applies, where I have applied a script. And the difference in this case is that we can also have our scripts work with model level properties. So I wish to test, in this case, with varying the number of cutting, welding, and shaping stations. And these are real properties that I've established that I wish to test each time. Rather, these are integers, real integer, very similar to one another. But I can go and test, let's say I want to have a combination of 2 cutting stations, 3 welding, and 5 shaping. I'm going to specify those parameters, and then my model will respond to those and create quantities that are in line with those values I've specified. So now we see we're running the new model, and we have that quantity that corresponds to the property related to it. Once more, if I was to say, let's find a new combination, I'll go to 6, 2, and 3. We're feeding those in, and then we're going to auto-create those of varying quantities. So all of this is enabled through our Python importer, where I am feeding in parameters to my import script that are telling the script how many cutting stations to consider, how many welding stations, and how many shaping stations. So in this particular script, these are numerical inputs to that. And then what is produced by the script, similar to the prior model, is going to be this table of objects that is going to create a row for each specific value I specify. So with 6, 2, and 3 for cutting, welding, and shaping respectively, we'll see that the importer is going to create 6 cutting rows, 2 welding rows, and 3 shaping rows. And once more, let's just show that from the data view, where now I have 10, 4, and 6. Let's make a large portion. And I go and run. Now we'll see that we have 20 rows that correspond to the 20 objects I've specified. So if you've done something similar to this in the past, you'll recall maybe having to make a unique spreadsheet for each specific iteration, whereas now that is merely a data change and is far more robust and seamless to work with. And so that's where this can be serving as an input to experimentation, or maybe I wish to set up a design of experiments where I'm going to toggle varying quantities of those workstations. So in this case, I can iterate through various combinations, and then I can run my experimental design with this importer driving the work for me. So those are 2 instances of where we would consider importers. And now revisiting our slides, let's talk a little bit about the exporters. So very similar as far as the workflow is concerned, but the exporters are more so on the aggregation of those results after a model's occurred. So a lot of the time, there's a lot of business flows and operational workflows that our customers have. And we don't want to disrupt how things are done to date. Rather, we want to be a supplement and augment those workflows, maybe to get further insights. So you could consider using an exporter to automatically generate business reports that are in a form that are in line with how you operate to date. So we can now use exporters to produce that, and we can also aggregate from multiple sources within the model into a single workable deliverable, as well as post results to those databases, APIs, with the simulation outputs. So another enabler to further get the results into the hands of the various stakeholders. So let's look at an exporter example. So in this particular model, let's assume that I'm working in a small surface mount technology facility, and I've collected statistics that capture the utilization of some various resources. So I have the hours busy of my resources, the utilization rates, and let's assume I also have captured material shortages of the various components needed to store my operation. So I have the quantities that are required, the quantity available, and I'm capturing the shortages, as well as a small production schedule showing what orders within my operation will be on time or late. So I've captured a few different output tables containing this information, but this is in a bit of a form that maybe for the executive leadership, it is going to be not quite in the most visualized form for what they need. Maybe we want to aggregate this into a business report that is more telling more immediately. So with that in mind, and once more, similar to the prior case, we're going to create an output script to perform this. So within this export script, once more, I'm going to specify the prompt that aggregates those tables into one single Excel summary output that I can more easily review the statistics of. So in this particular case, each output table, I'm going to feed into my exporter as an input. So I have a CSV binding, and then on that binding, I'm going to specify the file name that this is going to be in the name of, and then with my Python script, these CSVs will be aggregated and then put into a pandas data frame and then aggregated into an Excel spreadsheet that gives me those summary level statistics and results. So I take those three inputs, and then within my script, I'm going to open up my export script data, and then you'll note that I have all those CSVs referenced. So when I go and run this model, and I'm going to go here, we're going to run and fast forward to the end. So we ran our model, we got our results, and now within that, I'm going to export all the tables. So when I go and export the tables, in line with that export binding, we're exporting. And as that is going on, those all exported. And then when we go and review what was produced in our export binding, we'll see that we also have this daily production report that was generated by the script. So when we look at this daily production report, we'll load that up. So this is coming directly from the Python exporter, and it is giving me the summary of what took place in my simulation model. So you can treat this as a type of daily production report that could be produced, or it's going to tell me broadly what is the number of orders that were scheduled, how many were late, and it's going to give me a wealth of information about the performance of my simulation itself. And as well, we'll see the production schedule we saw in Simio, as well as the utilization, material shortages. So it's taking all that information from Simio and putting it into a form that is more conducive to how we operate as a business. So again, this is just similar to the importers, depending on the way in which you operate to date. If there's a need to generate results so that it is conducive to maybe your visualization tools, that being a Power BI or a Tableau or other resources, these exporters are a force enabler to ensure that is ultimately occurring. And just a few other things to note. So with any importers and exporters, an especially helpful window is going to be our output window. And so when going into this window, it is going to give you a bit more detail into the indication of whether or not an import or export was performed properly, and if there are certain errors involved, it'll give you error reports. So if we look at our exports here, it is going to give me that summary there of when I began that export and what binding was I using and all the relevant details there. If you look back historically, you'll see some more history of that, and the same is true of our imports. If you go into our import model and look at the imports, it is going to indicate the performance of that import. So especially with these importers getting these set up, the output window is going to be your friend. It's going to be quite helpful for that. For a lot of these details, especially these being rather new, and if you're new to Python, there's a lot of good information on our help page for getting these set up. So if we look at our import scripts in particular, there's going to be a nice symbit for using import and export scripts, gives you some example usage. So a nice help page here on discussion and examples. Also, this is particularly helpful for setting up your Python environment of how are things running and when. Talks about how you set up your IDE. In this case, I'm using PyCharm here today, but there's several IDEs that we can use. So this help page is going to be immensely useful to get your model up and running. In addition to that, please reach out to us as well, here to help understand these new features. Very exciting indeed. Moving along, so going back now, and let's continue on. So we're going to now look at visibility enhancements within process logic. So especially as we're building in processes within Simio, it is not always the most apparent as to where are we at in our process and what activity may be going on. And that's where these visibility enhancements help to uncover some of that unsuredness. So going into an example model here, we're going to look at how we can visualize the token count as well as identify what our current step is. So if we go into this particular model here, and what we're dealing with in this case is we have entities coming in, and we want to see within a process entities that are going to attempt to seize a resource. We're going to see that there's not enough capacity at that resource relative to the amount of demand for that resource. So as we initialize this here, let me pin back that facility view. We'll come in, and a very simple process here. We go into a server, and we attempt to seize that resource using a decide. It's probabilistic. And as we're running through, we're seeing that as these entities are getting stuck at the resource, or at the server rather, from the facility view perspective, there's not anything apparent to what's going on. But we'll see here that this resource is off shift. And in turn, when we go to look at our process, the token count is going to indicate to us that we are having several different tokens accumulate at the seize step that are waiting to satisfy that seize request. So that's one instance of where that may be effective. And we look below here, we have another process where we have, in this particular example, a server that is sitting at a wait step, and it is waiting for this release entities event to occur. And so until that event occurs, these entities are going to be sitting in that process and are going to be sitting specifically at that wait step while we wait for that event to occur. So you're seeing the accumulation of those entities and those tokens. And so especially as you're building out your model and maybe you're seeing some entities and some tokens getting stuck, that token count can be helpful to identify issues and maybe where we may need to make adjustments. But in this case, as I hit this button to fire an event, we then release the tokens and they're able to occur from there. So once more, and then we refresh our token count. So some nice features there, especially as you're working through process logic to identify issues and things of that sort. As well, if we're looking at maybe, especially in this particular case, this being one of our example models, as we run through this, we want to see and test, is our process working as intended? So on initialization, we're going to have this logic occur here, and I want to see when this logic is firing, where are we at in a point of evaluation. So this model is going to initialize here for a second, but then I want to have a little bit more visibility into if and when this process occurs. So we see we've hit a breakpoint. I'm going to add a trace here. As we run through, we'll see we are just at that assigned step. And then I want, within my navigation, I want to be taken to the current step that is exactly occurring. So as we run through, this current step will always point me towards what was the last bit of logic that was executed. And then the high priority we see is going to be the immediate next step that is evaluated. So the current step takes you to the most recently evaluated step. And especially if you have a model with several different processes, maybe each of which have a lot of logic attributed to them, that current step can quickly navigate you to where are we at within the calendar event space and help to identify what's going on in my model. So another way to further add some more detail to understand the model behavior. So if we look at the watch window is another instance of where we have some additional enhancements. And so this is helping to show a bit more of the collections of items that are existing in a given set of behavior. So in this case, we can look at how many tokens are in a process, what resources are seized by a particular object, maybe some different resource owners, reservation owners. This is just not meant to be an exhaustive list, but captures some of the things and the collections of items that you could view now with the watch window. So if we look at an example here, and let's start out with this particular case. So just another simple example model here, where we have entities come in, and these entities wish to seize a collection of resources as part of their need, and then they will process for 10 minutes from there. So the first entity comes in, and it is going to seize the set of resources. So when those resources are seized, we'll take a look at the watch here. And now within that watch, we're going to drop down. In previous versions of Simio, you could see the first item and last item, but we didn't have a set of information about the collection of items. But now if we look at this items option here, that allows me to drop down and see information about the set of items that are seized by this particular entity. And then within that, if there's a particular object or entity of interest, I can further drop down from there, and I have the set of information related to resource 1, and then I could get more information about it. And we continue this forward, and we have more entities come in and more attempt to seize the resources. We don't have the capacity at each resource relative to the amount of demand for that resource. So looking at it from a different perspective, now if we watch resource 4, and let's close out this entity. If we look at resource 4, now it is going to have an allocation queue that we can examine. And within that allocation queue, much like the prior example, the first and last are shown, but then we also have information about the collection of entities and items that are attempting to seize that resource. So in this case, we're seeing there's 18 different entities at this point in time that are trying to seize resource 4. And so especially if we're looking to add in some behavior, maybe doing some troubleshooting, this really helps to uncover what is being accessed in my model, where is that information coming from. Looking at it from the material perspective now, so going back here, we also have some information on stock reservations as it pertains to materials. So looking at our materials here, in this particular case, we're going to have entities come in, and as the entity goes, we're going to hit a process here where we're going to reserve stock. We reserve the stock, we get some notification, and then if I want to look once more at my watch here, on this entity, you'll note that this has a state on it for the storage area reference state. So it is in a particular storage area, and then in that drop-down, we get information about the stock quants as well as the stock reservations. And so within that, we're going to see the items involved and as well all the items of my stock quants. So especially if you're doing a lot of material handling and material storage work, this helps to give a lot more detail into some of the aspects there as far as bins, quants. There's a lot of detail that is helpful for further uncovering specific behavior within our given model. So a lot of good visibility features there that are going to be useful for modelers and users alike. All right, moving along. So also new to Simio now are some additional dashboarding options. So within any typical model to date, there were resource and entity Gannts that are available to users for review. But in the latest public release, we now have Gantt charts as an option for dashboarding purposes, as well as targets that can be used interactively in much the same manner. So if we go to our next model, so this is going to be a very familiar model to many of our users that have gone through scheduling discrete part production in our examples. But in this particular case, we'll look at how we can build out a dashboard interactively with the new tools. So if we run this model, this is dealing with a set of manufacturing orders, and we're going to get some different targets on ship dates and cost. And when we run this fast forward, as mentioned, any Simio model to date has access to resource Gannts and entity Gannts. But inside of our dashboards now, and let me pause that, if I go to open this and add in this new dashboard, you'll see now that we have this option to create a Gantt off of our DevExpress dashboards. So if I go to create a Gantt, it is going to prompt us to provide information very similar to other dashboards that we may have. So if I go to my manufacturing orders, or let's go to rather my manufacturing orders output for that matter, what we need to do is add text, start date, and finish date. So my text will be the order ID, the start date will be the scheduled start time, and then the scheduled end time. And very quickly we start to get some aspects showing up, but then we also want to see, let's group it by scheduled resource. So now we're going to see for each particular asset in this model, it is going to give us an indication, and let's also make that date time a little bit more specific. So let's filter it down to minute second. Now on each asset, with just a few drags, we have the beginnings of our new dashboard showing the orders and when certain jobs will take place at a given station. So save that off. Now we'll see that'll populate, and we have the beginnings of a new Gantt that we can do some different customization with. I've also added in another one that is very similar to the one we just saw, where if we go into our dashboarding tools, I wanted to create a dashboard that allowed me to filter down based on products and then based on order status. So what we're seeing is that I have order ID, and I have created a couple calculated fields to show the different start and end times of both on-time and late orders. So my calculated fields, I'm just showing if ship date is further out than due date, then we'll display the ship date, and vice versa for the other one here. But what this allows me to do is now I can pivot, and I don't want to save those, but now I can have a little bit more of an interactive dashboard than that of the Gannts here, where if I want to filter down to only look at my finished good A's, I can do so, and then I can also filter out my late portions, see how late orders are and whatnot. And I have a little bit more interactiveness with this Gantt than I would of our traditional Gannts. So just another nice feature that, especially if there's a particular workflow that you'd be interested in, you have those available to you. And also we have, as mentioned, various aspects for these targets that are able to be used in much the same manner. So if you've worked with RPS licensing at all, and the targets that are associated with the RPS features in the planning tab, those are now available for you as well. So pretty nice feature there. Moving along, there's also a set of other various user experience improvements. So one of which, especially in the nature of in tune with data-driven modeling, is now we have the ability to create data-driven queues. So if we go into this next model here, in older versions of Simio, you have the ability to create any number of queues, and you can manually do so, but as stated, you had to create queues previously by hand. Especially when we're dealing with these large settings, maybe like warehousing or something similar, where there's going to be a significant number of queues you may wish to visualize. Doing this by hand may be a bit arduous. So that's where this data-driven queue feature allows that to be done so far more seamlessly. So bear with me here one second. So in this particular case, I want to generate what we call a queue set. So this queue set is going to generate, as the name implies, a set of queues, and these are going to be defined within data to define the endpoints as well as any vertices as well. So going to this particular case, I am going to generate my queues, and I'm going to create a data table for that. So within this data table, I need to specify a state property, specifically of type queue state, and then I'm also going to want to define my X and Z points that are either going to serve as my endpoints or any vertices within that. And so within my queue set, I'm going to mention that they should reference this queue name column to access the set of queues there to define. And then when I add in my data set, so let me go back to my data. Now I define each particular queue state I wish to draw. And then I'm also going to define the endpoints and then the vertices. So adding that in, now we'll see that we're getting our queues starting to be developed. So with this particular queue set, we'll see that I now have 3 different queues drawn off of that. And so you could certainly add on to this for any amount of degree, and that could be taken to fully define all the queues that may exist in our model. So if there are instances where maybe we wish to define more than just one set of queues, maybe if we're doing some airport modeling or something like that, maybe we want multiple queue sets to visualize a queue more than one time in various orientations. So that's where there's going to be a slightly different feature where we want to add in on the queue set a discriminator. So once more, we'll go to our queue sets. I'm going to create 1. I'm going to create 2. And then we'll also see we have some different values that we can specify here. So in much the same way, I'm going to define to the 2 queue sets I wish to define. And the queue sets are going to be a string, and those are my discriminators. So this is going to designate to my subsequent table 1 the portion of the queue states that belong to each queue set. So if I want queue set here to belong to, I'm still going to specify my queue name. My discriminator key is going to be found in my table1.queueSet, and then I'm going to designate this queue set as that of, and let me also add in my keys here. So let me load in my data. So I populated my data, and I'm copying and pasting that from an Excel sheet on my desktop. But now I'm going to specify on each of these which queue set they belong to. So this is going to be Q1, and then this one is going to be table 1 queue name, queue set, Q2. And then as well for each of those, I'm going to populate my X, and then I'm going to populate my Z's. And then much the same here, my X and my Z. So now with those, when I go and run this model, we'll note that we just have 3 different servers here, each of which are just having entities go in them from selecting from list. But now I have my visual where I'm displaying the same queue, but interactively in 2 locations. So especially if there's certain aspects, or maybe if there's certain displays that would be beneficial to having multiple versions of the same queue, that's where you can add in these discriminator keys and discriminator values to specify the subset of the table schema that belongs to each particular queue set. So really this can be taken, especially as mentioned with the Python importer, these can be used in conjunction with one another to generate all the necessary queues that may be needed for your various modeling applications. Moving back here. So another aspect, we've also added in a significant enhancement as it pertains to animation of our objects and symbols. So new to the latest public release is the ability to display physically based rendering texture materials. So let's go to that model. So as we've added in more animation over time, and especially as we want to make our models look impressive and to be able to get the stakeholder buy-in, having a nice looking model is of paramount importance. And so with that latest enhancement, you'll see that these particular objects are loaded in as one of our 3D files. So we can add in our 3D symbols, add in our SketchUp, our Blender, whatever our 3D files may be. And then we can apply the texture to them, and they give them a very nice looking texture, so that as we continue to enhance, it is going to extend beyond maybe the animation of times past. And we can see even to the extent of having the gloss and shine of this couch here, really it is a nice high fidelity model for display purposes. These being just a couple examples that are pulled from online public repositories, but for your purposes, this can be added in depending on what availability to 3D files you may or may not have. On top of that, we also have the ability to add in skyboxes. So a couple examples here. So in our drawings tab here, rather our view, we can add in skyboxes. So being cognizant of time, I've already done so. I've pulled another from a public repository. But let's say if I wanted to do some street modeling or some applications that require me to do some roadway analysis, I can add in a skybox that gives my background a very nice looking feel so that as I'm adding in my objects, things are looking and in line with maybe the system I'm trying to define. So if I go and add in here, I can overlay my objects directly onto my skybox, and now my model adds a lot of animation fidelity and enhances the capabilities of what the model can do. Same as said here, but with a mall backdrop. Maybe if we're doing some holiday shopping, examining some foot traffic patterns, we can add in a skybox of a shopping mall. And so really the way to do that, we add in the skybox, and then if you wish to have the full display, we can remove the background color of the base to fully show the skybox in its totality. So really some nice looking animations there that really help to take that modeling fidelity to the next level for presenting it to larger stakeholder audiences. And we showed a little bit about the interactive Gantt display as it pertains to dashboarding, but we've also enhanced the display of the resource states within our base Gantt charts. So going back to the model we saw a little bit ago, in this particular case, when we fast forward, we're going to actually look at the base case resource Gantt in this case. So now within our assets, and particularly we'll focus on this cutting station, we'll see that the colors here are a bit more vibrant to help display what state is that resource in. So you see these green portions here indicate when the resource is busy and processing. The blue here is for when the resource is busy but conducting a setup. And then as well, we'll also see some other phases like the failed state. So that is when the resource, as the name implies, is failed, as well as when we're looking at any starved and idle time. In the gray is any off-shift time. So nothing behaviorally has changed, but it's giving a little bit more coloration to it so that it's much more apparent as to what state is the resource in. As we're reviewing modeling behavior, it's apparent to those end users. And then lastly, just another, and especially from a modeler's perspective, this one is particularly nice, is the ability to change the state column type when doing some data table work. So if we go to, let's go back here. So let's say we have a data table and we have a set of date times. And I need to, on model initialization, I need to put this into a state property for a set of behaviors. At first glance, I would assume that this is a date time property. So if I need to copy these over, I'm going to make a date time state. And I'm going to say times. So if we go and we're on initialization, I am going to, on run initialized, I'm going to search that table. And I'm going to search the entire table here. So I'm going to find rows. And then I need to assign that property over to the state column. So let's use an assign step. And that is going to be table1.times. And the value I'm going to copy over is table1.dateTimes. So we've added that in. And we'll add in time assignment. We'll just make sure we have properly name it. So when we go to run this, let's hit our breakpoint and our trace, fast forward. We find our 12 rows, but then we get this error. And the error suggests that that is in fact a string value rather than that being a numerical value. So in times past, we did not have the ability to change the type of state column that we did. So previously we would have to remove this and add in a brand new one. And especially if we have many states that we need to carry over, this can become a bit tedious from the modeling perspective to have to redo. But now that we've added in change type capabilities for the states, this is a much more easy conversion, or now I change this to a string. So rather than having to rename things, adding and deleting, once more I find my rows, and now those get copied over seamlessly. Completing this out, now we have our tables that are carrying this over. So doing this at scale, in this case, only one column may not seem so difficult, but when you're adding in these large scale tables with many different states, this really becomes a big time saver from the modeler's perspective. So with all that, we've gone through a lot of material today, went through a lot of topics. With that, I'll open it up to questions, and thank you for the time today.
All right, great stuff, Drew. So if we can bring up the questions that were asked, I know we have about 7 or 8 minutes left in the session. Perfect. All right, Drew, can I specify a particular IDE to edit my Python script in?
Yes, you certainly can do that. And within your settings, if I can share my screen to do so. So that. All right, within your settings, you have at the bottom, there is a scripting portion. And within that scripting portion, you can specify specifically the IDE you wish to use. So in my case, I happen to use PyCharm, but you can use a number of different sources, whether that be VS Code, Spyder. You have multiple options there for what you can use. So application settings is where you can find that. And that's also mentioned in our documentation as well.
All right, perfect, perfect. All right, next question. All right, about the Python integration, is it possible to interact with experiments in order to generate scenarios optimization driven by genetic algorithm or other heuristics?
Yes. So if you recall the second example I put together that had the 3 parameters that were fed into the Python script, that's one example of how you can use Python to be the means of scenario generation. I'm sure that could also extend to using opquest or other functions, but yes, those two can be worked in conjunction with one another for any number of purposes. If there's a particular type of analysis or experimentation you'd wish to perform, certainly reach out to us as well, and we can figure out the best approach for how those two can work together.
Okay, perfect. Let's try to get to 2 more questions here. Do I need to install Python on my computer to get the scripts to run?
No. So within the version of Simio that is the version 20, a temporary version of Python is installed automatically when you create your own script. So that is already going to be there. All you need to provide is the IDE that you wish to use to edit your script.
Okay, awesome. All right, 1 more maybe? All right, will these importers work if I want to pull data from a database rather than a spreadsheet?
Yes. So in my cases today, I focus largely on using Excel sheets, but if you wish to have a query or call an API for some command, that can all be done by putting that into the script itself. And then provided that you give the bearer tokens and necessary details, you can pull that data in as is needed. So should all be good there. Again, if there's more questions on a particular database you wish to pull from, reach out to us and we'd be happy to help offer suggestions.
All right, great. Any more questions? Nope, that's it on the questions. All right, real quick, if you wouldn't mind, very quickly, go back to the first slide where we had Drew's email address up there. There we go. Perfect. Thank you. So just in case, as Drew said, but if you have further questions, feel free to reach out. It's drose@simio.com. That would go directly to Drew. Feel free to reach out to him. And on the first slide that I had put up as well was my email address. So if for some reason you reach out to Drew and you're not hearing back, you can always reach out to me. Otherwise, we're going to come to a close there. Thanks for everyone attending today. If you're watching this on recording, thanks for coming in and watching the recording. As I mentioned at the beginning, we will be announcing some sessions here coming up for the remainder of the year as soon as we have them. You can look out for those in your email. Otherwise, thanks for attending, and we will talk to everyone soon. Goodbye.
Take care, everyone.